Congruent figures. You might have observed that leaves of different trees have different shapes. But leaves of the same tree have almost the same shape, although they may differ in size. The geometrical figures which have same shape and same size are called congruent, and the property is called congruence. Congruent objects are duplicates of one another. If two mathematical figures are congruent and you cut one figure out with a pair of scissors, it will fit perfectly on top of the other figure. Congruent triangles. So two triangles are congruent if the sides and angles of one triangle are equal to the corresponding sides and angles of the other triangle. This is the sign of congruency. The parts of the two triangles that have the same measurements, congruent, are referred to as corresponding parts. This means that corresponding parts of congruent triangles are congruent. In short form, we write it as CPCT. Criteria for congruence of triangles 1. We shall now learn that it is possible to prove the congruence of two triangles if we are able to know the equality of three of their corresponding parts. Consider a triangle ABC. Construct another triangle PQR such that QR is equal to BC, angle Q is equal to angle B, and PQ is equal to AB. If we trace or cut out triangle ABC and place it over triangle PQR, we will observe that one covers the other exactly. Thus, we may say they are congruent. Alternatively, we can also measure the remaining parts and observe that AC is equal to PR, angle A is equal to angle P, and angle C is equal to angle R, showing that triangle PQR is congruent to triangle ABC. This means that equality of these three corresponding parts result in congruent triangles. Thus we have criterion 1. If any two sides and the included angle of one triangle are equal to the corresponding two sides and the included angle of the other triangle, the two triangles are congruent. This criterion is referred to as SAS, side angle side rule. Criteria for congruence of triangles 2. The next criteria for the congruence of the triangles is that if any two angles and the side of one triangle are equal to corresponding angles and the side of the other triangle, then the two triangles are congruent. This criterion is referred to as ASA, angle side angle, or AAS, angle angle side rule. Let's solve an example now. In figure, PX and QY are perpendicular to PQ and PX, which is equal to QY. Show that AX is equal to AY. Solution. In triangle PAX and triangle QAY, angle XPA is equal to angle YQA because each is 90 degrees. Angle PAX is equal to angle QAY because these are vertically opposite angles, and PX is equal to QY. Therefore, by AAS congruence rule, triangle PAX is congruent to triangle QAY. Therefore, AX is equal to AY, CPCT. Assessment. Before proceeding further, let us know how much you have learned. Fill in the blank with correct options. Very good. Very good. Some properties of a triangle. Theorem. The angles opposite to equal sides of a triangle are equal. Let's prove it. Given is a triangle ABC in which AB is equal to AC. We have to prove that angle B is equal to angle C. Construction. Draw bisector of angle BAC meeting BC at D. Proof. In triangle ABD and triangle ACD, AB is equal to AC is given. Angle BAD is equal to angle CAD by construction, and AD is equal to AD common. Therefore, by SAS rule, triangle ABD is congruent to triangle ACD. Hence, angle B is equal to angle C. The converse of the